Okay, in this video, we show you how to write code for the servo motor. First of all, servo motor has 3 wires, which orange for the signal PWM, and then BCC red, and then ground for brown, brown for ground, and then for the period for the servo motor is 20 millisecond or 50 hertz. Then for the servo motor to turn most anti-clockwise is 1 millisecond, and then most clockwise is 2 millisecond, and in the middle is 1 millisecond. So if we are working with the clock frequency of 60 hertz, then we need to remember that for the period of for the 1 millisecond over 20 millisecond is only 5%, and then for the 2 millisecond over 20 millisecond is 10%, right? So for that reason, so I set here to 60 meg, and then FPWM to 50, and then division can be any, 2 or 4, for example, and then I set the PR to 10,000, because with that 10,000, whenever I have the I have the the name of this. So if I have 500 millisecond, 500 to pass 500 is already 5%. Then if I have 100,000, it is 10 second, 10%. Remember, I just can use from 500 to 10,000. So if I have, say that is 180, so 180 degree over 500. So I have for 1 tick is equal to 0.36. That's the reason why I choose the period of 10,000. Alright. So if we use the Arduino multi-function board, so on the multi-function board we have if you see here, so we have 3 pins, the first one, second, third, and fourth. And the first one is connected to timer 3 channel 1 or PV4. This is equivalent to Arduino Tidal 5 or Digital 5, which is PV4 for the STM32. So I'm going to use it. Right, so go to the pinout configuration. Okay, assume that I don't have this. I not set it yet. Okay. So first thing first, go to the pin PV4. Click it to select the timer 3 channel 1. Okay, if you're going to use it, I'm going to use it. You can use the timer 2 channel 3, for example, here PV10, right? It's up to you, but I'm going to use that pin. Next, go to the channel, okay, channel 1. So we select PWM generation on channel 1. So that one change to green. A clock source you can set to internal clock or just ignore it, right? But I set it to internal clock. Then we go to the parameter setting. Okay, so for the prescaler, just we set it to 10,000, right? Oh no, sorry, this one we set it to 120, I think. So go to the servo. So the prescaler is 40 for the division of 4. So let's say I use 1, so it is 120. So I set this one to 120 minus 1. -1, 10,000 -1. Okay, no division because we select 1, and then after reload, enable. Then after that, master slave disable because event to reset, right? Then PWM mode to mode 1, pulse, let it become 0. Then output compare, output compare enable. Pass mode we can set it to disable or enable, and then CS priority ensure high. Then go to the interrupt because I'm going to use interrupt, enable it, right? The next thing that I'm going to use here in this project is I'm going to use a push button, three push button. So PA1, PA4, and PB0 must be set as the input. That one you can refer to, okay, this one, switch PA1, PA4, and PB0. That's all, that's a tab. Then generate code. Okay. Okay, next, what we need to do is to include the core. Okay, so we need the switch and the userTick, userTick and switch.c, userTick.c in source, and then switch.h and userTick.h in include. That's all for the code. Then we go to the main. Of course, first of all, we need to include that two files, userTick.h and switch.h. Okay. Then right, and then in the code, first we need to set the timer in PWM mode for channel 1. This one, start the channel, the start timer in PWM 1, or sorry, in PWM. Start timer, what timer that? Timer 3, channel 1 in PWM. Then the first one I want to set, just whenever we set, we power up the project, then we move to the middle. Then we init a tick timer because we're going to use one only timer, C-stick, C-stick. So init a tick timer 1. Okay. Init tick timer. Actually, these functions we set tick 10 to the current system tick using how get tick. This one you must call it before we make use of get tick functions. So the get tick function that we're going to use is in if check and update tick timeout, check and update, this one. So this function actually must be called, function 2, check and update must this one to check it return -1 if not valid number, return 1 if timeout, return 0 if not timeout. So you can say that if check is equal 1, check and update tick timeout 0,10 equal to 1. That means if 10 milliseconds, then this if will be the statement will be true. So we check, first of all we check this state 0. So the state 0 is current state, that st1 is mean the previous state. Okay, so in this thing I have, this project I have do nothing, right, left, and middle. So I have 4 steps, do nothing, right, left, and middle. Okay, right. So whenever it is so here actually I just need 2 things only. First, memorize the previous state, so we can do anything here later, right, if you need. later. Then, for example, we want to flashing the 7 segment, for example, with number, with number, for example. So it's only one time here. But in this project, we not use it. We just memorize it. The second one, we get commands. I mean the switch. So if the switch, the S1 is pressed, this one S1 is pressed, then S3 not be changed to right. And then if the middle or S2 is pressed, then it will change to middle. And then if the most right, I think the most right S2 is pressed, then S3 not change to left, and then later we come back here and then we do that, either right, middle or left, right, middle or left. Okay, for the right one, so only first time execute here, nothing, we not do, we do nothing, and we just memorize. And then execute for each iteration. Here, what we're doing is we will increase the P pulse width until it is equal to actually maximum right. We increase by 10. We increase by 10. You can write it like this. I think it's better and more professional if you can write it like this. PWM equal to PW is plus equal 10. And then we update the timer. So we can see that the timer will be updated not gradually. Gradually by step of 10 until it is equal to maximum right. Okay. Then after that, then it will wait for the check the commands. So if the middle is pressed, then we jump to middle. Then if the left is pressed, right is pressed, then we jump to left. For the left side, then it will the servo will turn left until the PW is greater than, as long as it is greater than maximum left, then it will decrease. That means finally it become maximum left, maximum left. So but same, you can write it down like this: PWM minus equal sum of 10. So gradually we decrease the PW by 10 each time the left state is being called. Then update the timer 3. Here we get a command again, or push button. Then if the right mouse button is pressed, then we jump to right. The middle one is being pressed, then we jump to middle. In the middle, then first we need to know the current PW pulse width. I mean the previous pulse width. So if that is greater than midterm, then we set it as greater. If else, it is set to lesser. So if it is lesser, then we need to reduce the PW pulse width, or increase the PW. Increase PW until PW is equal to midterm, or the middle what dial of the servo letter. You can see. So this one same. And finally here we have, if PW all is greater, then we need to reduce it. So until it is equal to midterm. So PW minus equal 10. Then we update. So each 10 milliseconds, whenever all this being called, 10 milliseconds here, 10 milliseconds, then it's being called, then it will update the servo or the timer or the period, the pulse width or duty cycle of it. So you can see that the servo will move bit by bit, to the middle or right or most left. Again here, it will check if the button is being pressed. If right, then it jump to right. If less, then we jump to left. That's all code, right? So you can see it. So another code that you can see here that I use is bool pw all. I set to 0, right? Pw all, okay. This one, pw all, and then greater, right? Then here I have st to 10, 100, and then actually do nothing here. Then I have sw1, comma sw0 equal to 0. Then I set pw to midterm, right? So that this is the first one. I move to the middle point. Then here I have in the PV, I have define maximum right to 1280. Actually, we can have 1000 easily, right? And then this one should be 500, right? 500. However, it depends on the motor. So the servo motor, you can check it. So I changed this one to 220, so maximum left, 1280 to maximum right. Okay? If you put it to 1000, then it will not move under 80 degree. It's about 100 or 180 at 20 degree only. So it depends on the motor. You can test this one, up to you. Okay, then we have enumeration for greater and lesser. Then we have enumeration for the state. Do nothing, right, left, and middle. Okay, that's all. Then I compile. Then we can see it when I download it. Okay. Okay. Then now if I press button to left, this one to the middle. Oh, sorry, this one is to the right. This one to the middle. This one to the left. Right. Okay. So you can see it. Okay. That's all. Bye bye.